It has been an adventure getting here. It's only been a week. Ah, okay, so we're finally set up for our first recorded lecture here on Fundamental Chemistry 1, fall of 2020. What a year, huh? So, uh, already dropped my um, camera, destroyed my whiteboard. You'll see, you'll know. So you know, whatever. You just kind of roll with it. Let's do the best we can here. So we're ready for our PowerPoint discussion. Where can you find these PowerPoints? Well, you're going to go to lecture resources under our Blackboard, and underneath there you'll find all the PowerPoints you can download. And so this will be uh, a nice little overview. We're going to skip over a lot of the definitions. I'm going to come back, but I'm going to trust you to read those. A lot of this stuff on calculator practice, I'm going to come back and explain in class. It's a lot easier if you can follow along. But I might even just make another video on that. We're so hectic now. I mean, it's 11 o'clock and I'm just now getting recording this. So craziness. Let's jump into it though. So skipping a bunch of definitions, skipping all this sig fig stuff we've been working on. We'll come back, don't worry. But this video we're focusing in on metric and SI systems and learning how to do some of these conversions. Specifically, how do I do uh, these units? And so I'm going to focus a lot in my discussions on the units. All right, and so let's get a little bit of look down here. Look, my nice hole. Terrible. If I hadn't pointed out, you might not have never noticed. Okay. So one thing I would recommend if you're taking physics or chemistry or just about anything that's got any kind of measurements, that you come up with this idea of quantity, all right, and then the units, and then the symbol. And I recommend you make one of these for each of them. You might even come up with another thing if you wanted to, which system it's in. So, for instance, distance. All right. And so, distance a lot of times has an M for the symbol for it. The symbol for distance is either D or S. Um, Depending on what book you're in. All right. Uh, so you might, in the units here, M is in for meters. Okay. So you kind of need to learn that. But we have other units for distance. So we might see yards or feet. All right. And so you need to get all those kind of miles. Get all those in your head is distance. Now, what you really want to do is get used to thinking of what is the book going to want? What is the best, or not really best? What is the accepted? There we go. So each field is going to have a different accepted, and sometimes even when we get to doing these, we'll have different acceptance. So when we do pressure, for instance, it might be under psi. It might be torr. It might be atmosphere. And then everything that would, whoa, camera really doesn't like this hole. I'll fix it. All right. But the symbol for the pressure will usually be a P. Whoa. Disco music. All right. So let's erase it, see if maybe we can fix that thing. All right. Now we're just consistently blurry. All right. So when we're see a problem, it says something like 25 meters, 30 seconds. Um, 20 degrees. We need to be able to break this information down. And the easiest guide for how to do that is by learning to look at the units. All right, the units guide us through a lot of things. So when this is lowercase m, this is meters, and it's telling me distance. And when I see something that says, has an S, that's seconds, and it's telling me turn. And this, oh man, I'm back. I'm back. Yay. All right. So we were having a discussion about units and their guide. I had to turn off the autofocus. Got that figured out. So if you saw something that said 55L, you need to be able to figure out what it's talking about in a word problem. And so that's one of the things students struggle with the most. So this L is telling me that this is volume. And if I know that volume has the symbol L, it also has the symbol V in an equation, then that's going to save me a lot of trouble later. And so when I see something later that has units of mole, then I know this is an amount of material, and it usually has a symbol of a lowercase n. So when we get to seeing something that is 86 grams, I need to know what kind of system is that? Is that metric? And is it talking about mass? Is it talking about time? What's it talking about? So this happens to be grams. It's metric for mass. All right. And so you need to come up with a nice list, and you're just going to kind of expand on that as you do your reading. And you'll see a bunch of these, but most of them are pretty straightforward, but you might not be used to seeing them. Now, another thing that you have to be careful about the metric, the whole secret to the metric, is it uses this idea of a prefix. All right. And a prefix comes at the beginning. All right. So the base units we see in metric, then meter, liter, gram. All right. We even see seconds. Okay. So a prefix will come before those. And the secret to the metric system is to not try and memorize it like you were taught the English system. So you start off learning the English system, 12 inches equals 1 foot, right? And you learned a relationship like that and you memorized it. And then you said 3 feet equals 1 yard. And you memorized that. But that's not how the metric system's really set up. The metric system is more based off of set up like a lot like you would do some basic algebra. So 5 times x, and then we told you x equals 4. And you would put in and replace that x with a 4. And you would directly substitute it. All right, so don't forget, here's my little tear. Then 5 times 4, then you would say, oh, okay, that's 20. All right. And so we're going to replace now, the prefix goes in the front. And so these list of prefixes is pretty straightforward. We go through, come over here, and here's my list. And you'll have this table. It won't be exactly this one. It'll be a little more condensed. All right. It'll have all the same information. But this table is really helpful. And I'm going to just make it a little smaller over here. So you should be able to see it over here. There we go. All right. So, but the way you read this table is actually pretty straightforward. And you could write 1 milligram is so many grams, 10 to the minus 3 grams. You would also be correct to write 10 to the minus 3 grams equal 1 milligram. Okay? Both of those are the same, obviously, right? But what I'm going to recommend is you get in the habit of doing this top one, because you're going to write it a lot, and that seeing it over and over, that repetitiveness, it gives you a sense of familiarity. Familiarity. That's a mouthful, man. All right. So it looks like something you've seen before. Now, you probably will have some of you out there saying, hey, but I know 1,000 milligrams is equal to 1 gram. And this is true. This is, if you were taught this way, you were taught the same way you were taught the English system. And so at some point you memorized this. All right. And it's saying the same thing. This, remember, 10 to the minus 3 is the same as 1 over 10 to the third, which is the same as 1 over 1,000. All right. So 1 over 1,000, if I multiply both sides by 1,000, I'm going to get the same expression. Now, the problem with this system, I'm not going to tell you you can't do it, but I see time and time again students tell me, oh, but I know that system. And then they put the 1,000 on the other side. And here's the problem with that, because 1,000 grams equals 1 kilogram. And the problem they run into here is, which side does the 1,000 go on? Does it go to grams, or does it go to milligrams, or does it go to kilograms? And they get it confused. And it really only takes a couple of times of getting it backwards. And then they really start down the rabbit hole of putting it wrong every time. Now, if you're going to do it this way, the big number goes with the smaller unit. So milligrams is smaller than grams, so the big number goes there. Just like 4 quarters equals $1. A dollar is bigger, so it has the smaller number. All right. So that's how you handle that system. But this direct substitution, this is the way to do it. Now, I had learned it the other way. I learned it in 6th grade. I learned it in 7th grade. I learned it again in 8th grade. 9th grade, I had a break. 10th grade, learned it again. 12th grade, we took chemistry. I memorized all this stuff again. Graduate school, anytime I needed it, memorized it again. All this way through until I got, all the way up to my 2nd year teaching. And I had a young lady from a different class came up to me with a group of students, and they were asking me some of these dimensional analysis problems, struggling with it the same way many of you will. All right. And so she asked me how to do this problem, and I wrote down, 100 centigrams equals 1 gram or something like that. And she said, why are you doing it that way? And I remember it distinctly because it was Northern California. And she goes, like, why are you doing it that way? And I was like, oh, don't hit her, right? Uh, but then I stopped and listened to what she was saying. She said, just write 1 centigram, and a C is 10 to the minus 2 grams. And I said, okay. And I stopped and I listened. She was right. I went back and I thought on it. I thought on it. I said, man, I've wasted so much time memorizing this stuff. And I must have memorized this stupid prefix table over here. I mean, I've memorized this thing up and down. The great mighty King Henry did something I don't know. And man, I've already forgotten how to memorize it. We don't want to memorize it. We want it to be a nice skill that we use the same way every time. So let's do Terra. All right. So it says Terra, and it says it's the symbol T, and it's 10 to the 12. All right. So if I have a terabyte on my computer, it's got roughly 1,000 gigabytes, roughly 1,000 megabytes. Oh man, we learned the count the same way. I'll explain all that in a minute, but let's see. If I want to do a teraliter, it will look like this: a T and a capital L. All right. Oh no, I've got something that's 27 teraliters. I have no idea what to do with that. Well, what I'm going to write is my conversion factor is 1TL. All right, capital T. There we go. And I'm going to replace this T. This T is 10 to the 12. And so the 1 is still going to be here. We just usually don't write it. And I'm going to have 10 to the 12. And then this L just gets carried over here. So 1 teraliter is 10 to the 12 liters. Right? All I did was replace, directly substitute in off of that table. I took in that 10 to the 12 and brought it down. So now if I wanted to do this dimensional analysis, 27 teraliters, remember this is over 1. And I'm going to make these units cancel out. So teraliters need to be on the bottom, and then liters will be on the top. So teraliters on the bottom, liters on the top. Now the 10 to the 12 goes with the liters. Because I wrote it here, When I do this part, I don't have to do any hard thinking. It's already there. Now, there's got to be a nice, easy way of keeping up with this. Well, what I tell myself is the prefix down here always goes opposite the exponent. So the prefix goes opposite the exponent. So when I look at this visually, I can right away tell, hey, this is right. Whereas if somebody comes in and they write, and they have something like this, they might not immediately recognize that something's wrong. All right. But because I can look at this and say, hey, this exponent and this prefix should be opposite, always opposite, then I'll quickly tell, hey, they've got a mistake here. All right. And so I'll use that when I'm grading a lot of times. I'll look at your paper and I just kind of zone out, and look at it and go, oh man, something doesn't feel right in here. Kind of like when you try to look at a sailboat or something like that in the hidden pictures. Remember those? All right. So when you learn to count, you first learned to count 1 to 10. And man, you were proud when you could count to 10. You went around and you told everybody, hey, I can count to 10. Look at me. All right. And then you started counting to 100. Right? Because you took the tens and you put them with the one, and that's how you did it, right? And you could count to 100. Oh man, when you were counting by ones, then you could count by tens and count by 100. Then you took 100 and combined it with the 10, and well, now we got more like, all right. And so things falling apart. I wish I could show you what I did, but I just got to get more duct tape. All right. So you counted by 100. Then the language changed when you hit 1,000. Now you're really, because you get up to nine. That's ones with the 100. 999. See how that works? But when I hit 1,000, it's a new word. And then I can start combining these hundreds. 200,000. You right? 200,000, 50,000, right? So we can combine all that, but then we get to that 999, man, we all of a sudden we get to 1 million, and the language changed again. All right. And so let's see here. So this is 10 to the 0. This is 10 to the 1. This is 10 to the second, 10 to the third, and at a million, it's 10 to the sixth. All right. And then the next place that changes is a billion, 10 to the ninth, and then 10 to the 12th. Oh, what do we got? Trillion? And then I don't know. The only people that go higher than that are people that are dealing at the bank or something. They got way more money than me. They go any higher than that. Let's go smaller now. So when we're going smaller, we're going to go the same kind of way. 1 over 10 to the 1. That's the same as 10 to the minus 1, and 10 to the minus 2, and 10 to the minus 3. And then you got it, 10 to the minus 6. All right. And so it's that same kind of pattern. But you don't have to reproduce this. You just have to know how to use this. I'll give you the table. It's really the table. Learning the table is memorization. I want you to know how to use it. Okay. You can look that up. But we need to know how to use this pretty quickly. So if I see something that says 1 kilogram, I need to recognize first off, this is metric. First thing you got to recognize. And the fact that it's metric, then that helps me out a lot. So now I can tell I've got a prefix. And so I can just say 1 kilogram is so many grams. And then I'm going to read off the table and I'll find the K. And the K for kilo is 10 to the third. And so 1 kilogram is 10 to the third grams, right? So if I do 1 kilometer, guess what? It's still 10 to the third meters. Wonderful. So once you learn how to do this, you can do it with any kind of system. All right. All right. So now let's do one. Oh, let's do a tough one. Let's do a nanometer. Okay. The 1 nanometer is going to be so many meters. And nano is 10 to the minus 9. I just come over here on my table and I went nano And there's nano, and I go over here and it says 10 to the minus 9. It's that simple. All right. So this direct substitution really helps. All right. And so that's kind of the key to the metric system is once you kind of get a feel for the base system, then this direct substitution makes these really pretty easy. It's really just a matter of learning that the prefix always goes opposite the exponent. All right. So prefix opposite exponent. And I'll write this on uh, when I hand grade papers, I write this all the time. I may have to make a quick file, a macro to post this into Blackboard because I'll probably write this a bunch. Prefix goes opposite the exponent. Okay, so there's another key to the metric system that when we're going prefix to prefix, now there's a system of doing this that we could read the table and do it in one step. But when you're doing that, it's actually easier to think of it as two steps. We're going to always go to the base unit first. All right. So if I'm going centigrams to kilograms, I'm going to do the base unit first. Now, the base unit is this thing here. So I'm going to go centigrams to grams is 1 unit, and then grams to kilograms. And it is faster to do, we will do these kind of problems going to the base unit or from the base unit to a prefix. We'll do those all the time in metric system, and you'll get used to them. That's what we were just working on. And so it is faster to do that, something that we do over and over twice, than it is to stop and change gears and remember how to read this table a different way. All right. And the math on it works out exactly the same. If I showed you that way, you would be doing the same exact math, typing in the same thing in your calculator. It's just easier when we write this out to think of it as going 1 cg and looking up the centi is 10 to the minus 2 gram. And 1 kg is 10 to the positive 3 grams. Now, when I set this up, it's, so I don't know, let's say 22. This is made up. Made up. All right. Gotta write that a little bigger. All right. So 22 centigrams. And we're going to run out of space. We're going to go over here. Got so much space over here, I didn't realize it'd go all the way over here. 22 centigrams. Let's try it again. 22 centigrams. All right. And then this step, I want to go centigrams to grams. And then one more step, I'm going to go grams down here and kilograms up here. And you'll notice I set up the units. I'm looking down here, and I set up these. All I'm focused on, remember this is over 1. I'm focused on making the units cancel out. And that's the hard part. Once I have this part, which really just came from making these units cancel out, where did I get this again? Off the table, off this metric table. So metric to metric, the most we ever do is 2 steps. All right. Oh, I love that's metric system's awesome. Once I'm in the metric system, 2 steps for the hardest problems. Okay, so now I just need to fill this in. I need the numbers. Well, they're down here. 10 to the minus 2. And I can check that. It goes opposite that prefix. And 10 to the third. So when I read this, I'm going to have 22 times 10 to the minus 2 divided by 10 to the third. Now, putting this in your calculator can be a little fun. We're going to want to use the EE button. All right. Now, that EE button, let's explain it a little bit. So, when we're doing this EE button, it saves us so much trouble. So, when I have this something, let's do 1 times 10 to the 5th. All right. When I put this in my calculator, I want it to stay one number. This is one number in scientific notation. Well, if I put it in incorrectly, then I'll tell it it's 3 different numbers and I'm doing 2 different operations. And there's several different ways of doing it, but what our when our calculator does this, what it does is it takes all of this in this box and it labels it E. Now, we don't have access to just E, but we have access to EE. So when I turn on my calculator, it's second, and then it's above the 7, right in here. So let's go way up here. It's right in there, above the 7. But when I press that EE button, second EE, we'll see I pressed it. Whoa. Well, you guys can't see that at all. Too bad. It only puts one E. All right. So don't press it again. It's okay. Why does it say EE if it's only going to put one E? Well, that's because there's a little E over here that's the LN button by the LN. We don't want that. Then there's alpha E, and it just has whatever you have stored in it. But we want this E, the exponent E. And so that's got that E. So even if I had a number in front of it, so if I had 3.5 times 10 to the minus 8, and I want to tell my calculator use this number in scientific notation, then I'm going to put 3.5. Now notice the times and the 10 are built into this E. So I'm going to hit second E, E, negative 8. Make sure you use a negative, not a subtraction. All right. So when I see on my screen, it's going to write 3.5. And usually it'll put the E a little bit low, like that. And then negative 8. And it ties all this in as one thing. All right. Now, if you've got a 1 in front of that E, most of the time you're okay without that 1. All right. As long as you're talking about this 1 that's part of it. Okay. If you add an external 1, sometimes it can confuse your calculator. We'll look at main mistake students make is they put a 10E. They'll put 10E5. And this is wrong. Because that 10 is already built in. So that's wrong. All right. So when I come in and I'm going to type in this, I'm going to type in 22E negative 2 divided by E3. That easy. All right. And it ties it all together, makes it fast. This EE button, it's the least number of button pushes from there's 3 different ways of inputting some number in scientific notation or doing some of these exponents. This is the way to do it. It's the fastest and it gets your calculator you're speaking the calculator's language. All right. So that's how we do this metric system. So ooh, the blue doesn't want to erase. Nothing wants to erase. We got some RV erasers going on here. So the metric system is pretty straightforward. Then we have the English system. Things get a little more complicated. So when I do these, let's see if I have a nice handout here. When I do these, I'll have, oh, oh no, I don't got one. I'll have these numbers right. And all this is walked through in these guides here, these steps in dimensional analysis. All right. But when I do this slide here, and let's switch over to it. This slide here on that says conversion factors, this list here. Now, these are the normal ones that I give you. Now, the first 3 are all distance, and they're really interchangeable. You pick one of those that you like. All right. Now, the English system has stuff like miles and feet and yards and all this good stuff. Right? And so what you've got to do is look at a problem and decide. So this thing that I'm looking at over here, this conversion factors that you can't read now, all right, this conversion factors here. When I give this to you, I'll give you a handout and it'll be on the back of the periodic table. And it's got 2 columns. First, it's going to have over here a table of prefixes, and then it's going to have this list that says conversion factors. And then it's going to have some stuff down here, and these turn out to be solubilities. We don't have to worry about that till a long time. Chapter 6, maybe even chapter, and then we'll have chapter 2. We'll see some stuff over here that we probably won't use, but I can include for you. All right. So why do we need this stuff up here is metric to metric, and you can't see the green at all. I'll just rewrite it. Metric to metric. There we go. All right, so metric to metric, that's that table that we talked about that would have the prefixes. Okay. This table here is only for metric to English and English to metric. And so the first step then is figuring out what system are your units in. So when I do metric to English or English to metric, I've got to figure out which system it's in. So English system is a list. And so I don't include that list. So let me go ahead and I'll give you a list of the basic conversions that I expect you to know if you're going to be in my class. So these are the English conversions that you're just going to have to know. So, all right, you ready? Here we go. You need to know 12 inches is equal to 1 foot. And you need to know that 3 feet equals 1 yard. Oh man, our next question I usually ask is how many feet are in, how many yards are in a mile? Nobody ever knows that. Don't worry about it. Let's see, what else are you going to need? Oh, you're going to need 60 seconds equals 1 minute. And then you're going to need 60 minutes equals 1 hour. And then you're going to need to know 24 hours equals 1 day. Oh, and 7 days equals 1 week. I need you to know that 10 dimes equals $1. And 4 quarters equals $1. Oh man, I could ask you about pints and gallons and cups. You know what? I'm not. If I'm going to do any of those, I'll give them to you in the question. If it's in English, one other than this. For instance, in lab, we're going to use 2,000 pounds equals 1 ton. Most people don't know that. Most people don't use it unless you're dealing with elephants or cars. Man, learn that one at the zoo. All right, so English to English, you get it out of your head. If it's not in your head, I give it to you. Metric to metric, you're going to go to that prefix table. Remember, if it's one prefix to another prefix, then you're going to have to go to the base unit first. All right, English, metric, and metric to English. You're going to that list that says conversion factors. All right. And you want to use one only. One only. Don't use a bunch. So when I come over here to my list of conversion factors, all right, if I'm doing inches to centimeters, I'm going to use one of those. So you want to think these as if you're crossing the road, okay? So you don't, let's say you got to go down 3 blocks and you got to cross the street. It doesn't really matter if you cross the street and then go down, or if you go down and then cross the street at the end, or if you go down a block, cross the street, and then go down the rest of the way. The key is you're going to cross over one of these systems one time. Me, I like to get into the metric system and work in the metric system. Why? It's a max of 2 steps, and once you get used to it, it's really pretty straightforward. All right. Some people like to do the English system as much as they can. That's fine. You can go halfway, and that's actually what we see here. These list of things here. So if I'm starting with inches and I'm going to miles, then I have all kinds of choices. I could immediately go inches. Well, I'm sorry. If I'm going inches to kilometers, let's do something like that. So inches to centimeters, centimeters to meters, and then because that's metric, and then it's just centimeters to kilometers. Very similar to what we did a while ago. I could go inches to feet, feet to yards, and I could cross from yards to meters, and then meters to kilometers. That'd be one step in the metric system. I could go inches to feet, feet to yards, yards to miles. That's the one that most people miss. 1760 yards is 1 mile. And then I could go miles to kilometers. So that's why I include those three. So you have your choice. Now you'll notice when we get to mass here, 1 kilogram equals 2.205 pounds. I'm not giving you a bunch of options. Now, where people get confused is they go back and forth. I'll get people go inches to centimeters, and then they'll go centimeters to meters, and then they come back to yards, and then they're trying to go yards back to miles and miles to, and they're trying to do everything. They're just looking on that list of conversion factors and using anything they want. We want one off of that, right? One off of that. Now, I've got some other lists down there for stuff that we won't use as much. All right, so you've got all kinds of information, and we will be practicing it this week and next week in lab. But it really comes down to looking at the unit. All right, I'm going to stop it there. I'll give us some more tomorrow, record some more, and I'm going to upload a bunch of stuff for you. So you guys take it easy. Remember, we're taking it easy this semester. All right.